show me you're okay. Yeah, no, yeah. All right, so let me go back to my a fresh page here. I just want to kind of go through each of the steps here. So, okay, so normal distribution, we think of it as a bell curve. We've seen that before. And data is structured in this way. If it's a normal curve, it's always going to have these percentages across. Okay. So the middle is the mean. This the average, right? And everything is going to kind of spread away from the average. There usually is going to be, if it's a normal curve, there's going to be the cluster is going to be around the mean, and then the edges are going to be, where the extremities are. I think an example that we can all relate to is test scores, right? If there's an average of that average test score, most students are going to be scoring around that average, and then there's always going to be, then the students who are scoring a lot higher and a lot lower will be fewer, right, around the extremities. Okay, so it's formed by using mean and standard deviation. The total area under the curve is 100%. Because it represents all the probability, and the probability is 100%. Okay, so we're using probability to figure out, what's the probability of a student or of a percentage, or if we think about test scores here, what's the probability of a student scoring below this or scoring above a value? Okay, so the empirical rule is 68, 95, 99.7. Okay, so this is the percent or probability of the area under the curve for each standard deviation shown on the graph below. Okay, so it kind of separates the spread of data. So in the center, okay, 68% of the data is going to be here. It's going to be split evenly, 34 and 34. And then as we move further away, there's less percentage, but it's all going to be symmetrical here, 13.5%. And then even further away, we have 2.35%. And then this small little region looks like there's not much there. It's 0.15%, so less than 1%. Okay, same thing on this side. Okay, now if you were to add up all this data, all these numbers up, it'll be 100%. If you're only to take what's to the right of that 34, then you're going to see 50%. Okay, so if I add up all those numbers there, it would add up to 50. If I add up all these numbers here, it'll be added to 50. Okay, so here's the mean. The mean is x bar. So in a normal curve, most students are going to be clustered around the mean. And then every bar, every vertical line is one standard deviation away from the mean. So here, this is a standard deviation more, so plus, and you see that I'm using that lowercase sigma here, so plus 1 sigma. And then here, the second interval will be x bar plus 2 sigma. And then this last bar there will be x bar plus 3 sigma. Okay. Same thing here, but instead of adding standard deviation, I'm going to be doing what? There's x bar minus, yeah, x bar minus sigma, x bar minus 2 sigma, and then finally x bar minus 3 sigma. Okay, so the normal distribution curve is used to find the probability. It it must be a normal distribution in order for us to use these above percentages. Okay, so obviously not everything is on the normal curve, but assuming that assuming data is falling along a normal distribution, we're going to use this use the data above. Okay, so for a normal curve, find the following probabilities of a randomly selected x value for the distribution. It may be helpful to use a sketch. Okay, so I want to find the probability of students scoring less than two standard deviations to the left of the mean. Okay, so I want everything to the left of this x bar minus 2 standard deviation. So here, I find that line, right? I want everything less than, so I'm only going to be adding those two together. So this is less than means to the left of. Okay. So if I add those together, what do I get? Okay, right. So this is 2.35% plus 0.15%. Now that's the percentage, but in decimal form, it'll be 0.025. So it's good to know percentage, but it's also good to know that we want to present our answer as a decimal. So just take your percentage decimal and move it to the left. Okay, so here I want to find the probability of a student scoring to the right of x bar plus 1 standard deviation. So 1 standard deviation is going to be here. So I want everything, I want to add up all the percentages to the right of that line. Yeah, let's just go ahead and find both. Let's find the percentage and let's also find the decimal representation. Okay, any questions there? So when you see greater than, that means you're adding all the numbers to the right of that dividing line. If you see less than, that means you're adding all the numbers to the left of that dividing line. Now, what does this notation mean for C? Everything between, sorry. Okay, my screen froze. But everything between x minus 2 bar and x plus 2 sigma. So we're going to add up all the percentages between these two dividing lines. So 13.5 plus 34 plus 34 plus 13.5. Oh, I'm sorry. Yeah, sorry, over here. Okay, does that make sense to everyone? Okay, so go ahead and see if you can try D, E, and F. after this, we're going to do number 3 on page 16, and then we'll be done for the day. Okay, so we're going to create a specific scenario looking at number 3, but check with my answers first. So again, less than means you're going to add up all the percentages to the left of that dividing line. Greater than means you're going to add up all the percentages to the right of that dividing line. You see two inequalities. That means you're going to be adding all the percentages between the 2 dividing lines. Okay, let's go to page 16, and we're just going to look at number 3. Okay, page 16, number 3. Any questions? All right, page 16. Very good. Let's go to number 3. All right, a normal distribution has a mean of 25. So now, instead of just giving us x bar plus or minus sigma, we're going to actually be able to find, use specific numbers here. So a mean of 25. So at that center line, go ahead and put 25. Standard deviation of 5, that means every time we're moving a standard deviation away, we're going to either add 5 or subtract 5. So to the right, I'm going to add 5 to each line there. 25 plus 5, 30 plus 5. Oh, sorry, I don't need that 45 there. I should need 3 standard deviations away. Okay, subtract 5, so that's our standard deviation. We're going to either add or subtract this number every time we move to the next bar. Now the percentages will stay the same. This is a normal curve. We just want to get comfortable with the decimals. Instead of the percentages, we're going to use the decimals more, 0.0235. Okay, between 20 and 30. Okay, between 20 and 30. So here we go. 0.68, right? Okay, between 10 and 25. Between 10 and 25. Okay, between 15 and 35. Okay, sometimes students get stuck with the wording here. What does at least 20 mean? 20 or more, good. At least 20 means 20 or more. Sometimes we get thrown off. We see the word least, we think that is to the left, but it's gonna be to the right, 20 or more. So that means we wanna look to the right of 20. Now we can save a little bit of time. We don't have to add all these percentages up because what do we know about this piece right there? 50, right? So just do 50 or 0.5 plus 0.34. You don't have to add up all those numbers, especially if you know that half the data is only 50%. At least 35, that means 35 is the smallest, and we want to go from 35 all the way to the end. So 35 or more. Okay, what does at most 30 mean? 30 or less. Yep, 30 or less. So everything to the left of 30. Okay, so again, it's 50% plus that 0.34, right? Okay, we're ahead. That's good. We can buy some more time in terms of having another extra review day. Okay, let me check your worksheets. I'll check 13, 15, 16.